Hi, today we're going to be doing an overview of the concepts we've learned about patterns, and we're going to be expanding on that a bit, and then we're also going to do some extra practice. So first let's have a look at patterns with a constant difference and remind you about those. When a pattern is increasing or decreasing by a constant amount, it has a constant difference. Okay, so here's an example. We've got the pattern 3, 6, 9, 12. To get from 3 to 6, we need to add 3. Then from 6 to 9, we also add 3. And from 9 to 12, we also add 3. So in this one, we've got a constant difference of 3. And our rule for this pattern is Tn equals 3n. Then here's another example. We've got the pattern 9, 7, 5, 3. So in this one, it's decreasing, and every time we are subtracting 2. So we go minus 2 to get from 9 to 7, we subtract 2 to get from 7 to 5, and we subtract 2 to get from 5 to 3 as well. So our constant difference in this pattern is negative 2, and our rule for this pattern is Tn equals negative 2n plus 11. So when you have a pattern that has a constant difference, then you work out the constant difference by taking any term and subtracting the term before it. So over here, if I take 6 and I subtract the term before it, it's 3. That will give me 3. If I take 9 and I subtract the 6, it'll also give me 3. If I take 12 and I subtract the 9, it'll also give me 3. Or over here, if I take the 7 and I subtract the 9, I'll get negative 2. Or 5 minus 7 is negative 2, and 3 minus 5 is also negative 2. So that's how you can work out your constant difference. And then once you've worked out the constant difference, you multiply the constant difference by n, and then you see if there's anything else you need to do to get the pattern that you've been given over here. Okay, so that's patterns with a constant difference. Then you also get patterns that have a constant ratio. Okay, when each term in a sequence is multiplied or divided by the same number to get the next term, then the pattern has a constant ratio. So here's an example of a pattern with a constant ratio. The pattern goes 1, 2, 4, 8. So in this one, I can't just add the same amount every time. If I add 1 to get 2, then I can't add 1 again and get the next term. It's not going to work. So this isn't a constant difference. This one has got a constant ratio. If I take the 1 and I multiply by 2, then I will get 2. And if I multiply by 2 again, I will get 4. And if I multiply by 2 again, I will get 8. So this is what we call a constant ratio. And in this case, the constant ratio is 2. It's the amount that we are multiplying by. Okay, so our rule for this pattern is Tn equals 2 to the power of n minus 1, where the base of the power is our constant ratio. Okay, now you can also get patterns where the terms alternate between positive and negative, and when that happens, it means that the constant ratio is negative. Okay, so in this example over here, we've got 2, negative 6, 18, negative 54. So you can see it's going positive, negative, positive, negative. So it is alternating. And that means that our constant ratio is going to be negative. Okay, so over here, if I go from 2 to negative 6, I need to multiply by negative 3. And then when I multiply by negative 3 again, it's going to give me positive 18. When we multiply by negative 3 again, it's going to give me negative 54. So that's why it's alternating, because I'm multiplying by a negative all the time. Okay, so in this case, our constant ratio is negative 3. And the rule is going to be Tn equals 2 times negative 3 to the power of n minus 1, where the base of our power is the constant ratio again. But this time you have to be careful that you need to put that in brackets. If you don't put it in brackets, then you're only going to be raising the 3 to the power of n minus 1 and not the negative as well. And remember, your ratio is negative 3. It's not just 3. Then you also have this over here, this 2, which is the same as the first term of the pattern. We didn't have anything like that in the last one because the first term of the pattern was a 1, and so we didn't have to worry about writing that. But when the first term of your pattern isn't a 1, then you do need to write that over here. You need to multiply it by the constant ratio raised to the power of n minus 1. Okay. Then we also get patterns when we have a constant ratio where the terms are being divided by something to get the next term. Okay, and when that happens, we need to tip in times to find out what the ratio is. So in this example over here, we've got the pattern 9, 3, 1, a third. So you can see it's being divided by 3 all the time. So if I go from 9 to 3, I'm dividing by 3. If I go from 3 to 1, I'm dividing by 3. If I go from 1 to a third, I'm dividing by 3. But the problem is that the constant ratio isn't what I'm dividing by, it's what I'm multiplying by. So I need to change this division into multiplication to actually get my constant ratio. So over here, this is the same as multiplying by a third. I tip and times. So 3 over 1 If I tip in times, it becomes 1 over 3. And this is also times a third, and this is also times a third. So when you are dividing, you need to tip in times to find out what your ratio is. So the constant ratio here is 1 over 3. And our rule is going to be 9 times a third to the power of n minus 1. Again, the base of our exponent is going to be a third, which is our constant ratio. And just like the last one, I need to put it in brackets. This time is because it's a fraction. And if I don't put it in brackets, it means that that exponent is only going to apply to the numerator and not the whole fraction. So I have to put it in brackets so that the whole fraction gets that exponent. And then I multiply. So over here, the base is my ratio. And then I'm multiplying by my first term, which is the 9 over there. Okay, so those are our patterns with constant differences and constant ratios. But you also get other kinds of patterns as well. Not all patterns have a constant difference or a constant ratio. Okay, so here we have an example of a pattern that doesn't have a constant difference or a constant ratio. It goes 1, 4, 9, 16. I want you to see if you can figure out what the next 3 terms in the sequence are. And I also want you to see if you can figure out what the rule is for this pattern, and then use that to help you to work out what the 9th term in the pattern will be. Okay, so I'm going to give you 2 minutes to work on this question. Okay, so let's go through that and see what you should have got. So over here I've got my pattern 1, 4, 9, 16. Now I already told you that this pattern doesn't have a constant difference or a constant ratio, but let's just quickly go and check. So if I go from 1 to 4, I would be adding 3. But if I go from 4 to 9, I can't add 3, I need to add 5. Again, if I go from 9 to 16, I also can't add 3, I would add 7. Now let's also just check and see if there's maybe a constant ratio. So to work out the constant ratio, I see what would I need to multiply this by to get that. I would need to multiply it by 4. But if I want to go from 4 to 9, I can't multiply by 4. It's not going to work. Okay, I can't multiply 4 by 4 to get 9. So I don't have a constant ratio, and I also don't have a constant difference. But if you look at this over here, 3, 5, 7, even though it's not a constant difference, it has a pattern of its own. If I take that 3, the 5, and the 7, I can find a constant difference for those over here. From 3 to 5, that is increasing by 2. From 5 to 7, that is also increasing by 2. Okay, so this is an example of a pattern where we have a second level of differences which is constant. The first question we had to do was to find the next 3 terms. Okay, so to find the next 3 terms, if I see over here that I have a pattern in the differences, it's going 3, then 5, then 7, Then my next one, I'm going to add 9 to get my next term. So 16 plus 9 is going to be 25. So the next term that you got should have been 25. Then you would have to add, after adding 9, you would then add 11. Okay, so our next term is 25 plus 11, that is 36. And then we would add 13 after that to get our last term that we have to do, which will give us 36 plus 13 is 49. Okay, so those are the 3 terms that you should have got for question A: 25, 36, and 49. Okay, so now let's go and try and see if we can figure out what the rule is. Okay, now you may have noticed that these numbers are actually special numbers that you might recognize. These are our perfect square numbers. 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, 36 is 6 squared, 49 is 7 squared. So this pattern over here is actually the square numbers, and each time we're taking the term number and we are squaring it. So it is n squared. So that is what your rule should have been. Tn is n squared. And then for question C, we had to work out what the 9th term in the pattern is. So now T9 is equal to n, which is 9 squared. And that should have given you 81. So the 9th term in this pattern is 81. Okay. So now this, like I said, is an example of a pattern that doesn't have a constant difference and it doesn't have a constant ratio. This is a pattern that has a second level of differences that is constant. It is an example of a pattern that we call quadratic. Okay, so let's have a look at our quadratic patterns. When you have a pattern where the second level of differences is constant, then the pattern is quadratic. And when you have a quadratic pattern, the rule will contain n squared, like in the one that we just did. The rule was Tn equals n squared. Okay, now it won't always be equal to n squared only. There will be other stuff as well. It might be 2n squared or 5n squared or n squared minus 3 or something. But it will contain n squared. Okay. Here's an example of a quadratic pattern. This is the one that we actually just did. 1, 4, 9, 16. This is your most basic quadratic pattern, the plain square numbers. So if we go from 1 to 4, we are adding 3. If we go from 4 to 9, we are adding 5. If we go from 9 to 16, we are adding 7. And so this, the 3 and the 5 and the 7 form a pattern of their own. They have a constant difference of 2, like that. Okay, so our second level of differences is constant. And when you have a pattern like this, then the rule is going to be Tn equals n squared. Okay, now here is another example of a quadratic pattern. We've got the pattern 3, 12, 27, 48. So let's have a look at our differences here. So from 3 to 12, we need to add 9. Then from 12 to 27, we need to add 15. And from 27 to 48, we need to add 21. Okay, so over here, from 9 to 15, this has a difference of 6. And from 15 to 21, it has a difference of 6. So our second level of differences, once again, is constant. The rule for this pattern is Tn equals 3n squared. So once again, it contains that n squared because it is a quadratic pattern. Okay, then here's another example. We've got the pattern 6, 9, 14, 21. In this pattern, from 6 to 9, we are adding 3. From 9 to 14, we are adding 5. From 14 to 21, we are adding 7. And then that forms the pattern where we have a constant difference of 2, just like we had in the plain n squared. So our rule for this one, Tn equals n squared plus 5. Okay, so those are some examples of quadratic patterns. Then you also get something called cubic patterns. If there is a third level of differences, which is constant, then your pattern is cubic. And then the rule will contain n cubed. For example, over here, we've got the pattern 1, 8, 27, 64, 125. Okay, so if I go from 1 to 8, I'm adding 7. From 8 to 27, I'm adding 19. From 27 to 64, I'm adding 37. From 64 to 125, I'm adding 61. Okay, then from 7 to 19, let's check the second level of differences. Here I'm adding 12, then I'm adding 18, and then I'm adding 24. Again, they're still not constant, but now you can see that they look more like a pattern. If I check the differences again, you'll find that from 12 to 18 you're adding 6, and from 18 to 24 you're adding 6. So here we've got 3 levels of differences, and on the third level of differences it is constant. This is a cubic pattern, and the rule for this pattern is n cubed. If you check all of these numbers, these are actually our cube numbers, our perfect cubes. So I've got 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Okay, so those are our cubic patterns. So now we've learned about patterns that have a constant difference. We've learned about patterns that have a constant ratio. We've learned about patterns that have a constant second level of differences, which are our quadratic patterns. And we've learned about our cubic patterns, where the third level of differences is constant. Okay, now I'm going to give you some that you need to go and practice finding the rules for these patterns. Okay, so I'm going to give you a few patterns, and all you're going to do with these patterns is find the rule. I'm going to give you 1 minute for each one. So here's the first one. I'm going to give you 1 minute to find the rule for this pattern. Okay, so let's go through that and check it quickly. So here's my pattern: negative 10, negative 20, negative 30, negative 40, negative 50. When you get a pattern and you need to find the rule, the first thing you should always do is check for a constant difference. Okay, so over here, if I go from negative 10 to negative 20, I'm subtracting 10. Then from negative 20 to negative 30, I'm subtracting 10. From negative 30 to negative 40, I'm subtracting 10. From negative 40 to negative 50, I'm subtracting 10. So I've got a constant difference over here. Okay, so remember, when you have a constant difference, your rule is going to be Tn equals the constant difference, negative 10, multiplied by n. And then you need to check and see if the constant difference is the same as the first term. So in this case, they are the same, so I don't need to do anything else. That is our rule. If it wasn't the same, I would then need to see what I need to do to get it to be the same, and add or subtract over here. Okay, but in this one, that is all you have to do for that pattern. Okay, so now we're going to go on to the next one, question B. You've got the pattern 5, 15, 45, 135, 405. I'm going to give you 1 minute for this one as well. Okay, so let's go through that. Right, so in this one, like I said, the first thing we're going to check for is a constant difference. So from 5 to 15, I'm adding 10. From 15 to 45, I'm adding 30. So that's not a constant difference, okay? Now, the next thing we're going to check for is a constant ratio. From 5 to 15, I'm multiplying by 3. From 15 to 45, I'm multiplying by 3. So because those are the same, I'm going to assume that it's the same all the way through. So let's now go and check. So from 5 to 15, I'm multiplying by 3. 15 to 45, I'm multiplying by 3. 45 to 135, I'm multiplying by 3, and 135 to 405, I'm multiplying by 3. Okay, so my constant ratio here is 3. So my rule is going to be Tn equals, now I'm going to take the first term, which is 5, and multiply it by my constant ratio, which is 3, to the power of n minus 1. So that's what you should have got for question B. Right, question C. You've got the pattern 2, 5, 10, 17, 26. I'm going to give you 1 minute again to find the rule for this pattern. Okay, so let's go through that and see what you should have got. Okay, so first of all, if I check for a constant difference, 2 to 5, I'm adding 3, 5 to 10, I'm adding 5, so it's not the same. Now let's check for a constant ratio. To get from 2 to 5, I have to multiply by something strange, and then from 5 to 10, I'm multiplying by 2, so it's not going to be the same. So I don't have a constant ratio. So now let's go and check what our second level of differences is going to be. So from 2 to 5, I'm adding 3. Then from 5 to 10, I add 5. From 10 to 17, I add 7. From 17 to 26, I add 9. Okay, so you can already see that that is forming a pattern over there. So here I've got a second level of differences where it's plus 2, and plus 2. So when you get a pattern where the second level of differences is constant, you know that you're going to have a rule that is Tn equals, and then you're going to have n squared in your rule. Now we don't know what the rest of the rule looks like yet. When you get a pattern like this, look at what the pattern would be if it was just n squared. So compare it to your square numbers. Okay, so I'm going to just write it, the square numbers above over here. I'm going to say this. The square numbers are 1, 4, 9, 16, and 25. And see what the relationship is between those and the numbers in my pattern. So over here, from 1 to 2, I can either add 1 or multiply by 2. Then from 4 to 5, I can add 1. And from 9 to 10, I can add 1. 16 to 17, I can add 1. 25 to 26, I can add 1. So all of these, if I add 1, I will get that pattern over there. So that means that my rule over here is going to be the same as the square numbers plus 1. Okay, so my rule for that pattern is n squared plus 1. Right. Now, question C. You've got 3.5, 4, 4.5, 5, 5.5. And to give you a minute to find the rule for this pattern as well. Okay, so let's go through that quickly. So over here is my pattern. To get from 3.5 to 4, I add a half. From 4 to 4.5, I add a half. From 4.5 to 5, I add a half. And from 5 to 5.5, I add a half. So this is a constant difference of a half. Okay, so my rule, Tn, is equal to, I'm going to take my constant difference and multiply that by n, so half multiplied by n, so it's half n. Then I need to see what do I need to do to get from a half to 3.5, because they're not the same as each other. To get from a half to 3.5, I need to add 3. So my rule is going to be a half n plus 3. So that's what you should have got for the rule for question D. Okay, now let's go on to question E. Here we've got -1, -8, -27, -64, and -125. I'm going to give you a minute to find the rule for this pattern as well. Okay, so let's go through that and see what you should have got. Okay, so first of all, if you look at this over here, you should have seen that there isn't a constant difference and there also isn't a constant ratio. So now we're looking to see what our second level or our third level of differences looks like. Okay, so I'm going to start off by finding my first level of differences. So from -1 to -8, I'm subtracting 7. From -8 to -27, I'm subtracting 19. From -27 to -64, I'm subtracting 37. And from -64 to -125, I'm subtracting 61. Okay, then from -7 to -19, I'm subtracting 12. From -19 to -37, it's 18 that I'm subtracting. And from -37 to -61, I'm subtracting 24. Okay, still not the same. So now we're going on to our third level of differences. From -12 to -18, I'm subtracting 6. And from -18 to -24, I'm subtracting 6. So because I got to a third level of differences, which was constant, that means that my rule is going to be n cubed. Okay, so Tn equals n cubed. It's a cubic pattern. Now I need to go and compare this to what the normal cubic pattern would be with just the plain cubic numbers. Okay, so just like I did when I was doing the quadratic pattern earlier, I'm going to write down what the cubic numbers are and compare them to what I've got in this pattern over here. So my cubic numbers, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Okay, so if you look at the normal cubic numbers and the numbers that I've got in my pattern, they are very similar, except that these are all negative and those are all positive. But otherwise, they look the same, okay? Now, what that means is all I need to do to get from those numbers to these numbers is I need to change the sign. And how do we change the sign of something? We multiply it by -1. So that means that this is going to be Tn equals negative n cubed. So that I'm multiplying the n cubed by -1, or changing the sign of n cubed. So that is what your rule should have been for question E. Right, now I'm going to go on to question F. You've got the pattern 2, -4, 8, -16, 32. I'm going to give you 1 minute for this one as well. Okay, so let's go through that question. Okay, so now for this one, the first thing you should have noticed is that you've got alternating signs here. You've got positive and negative and positive and negative and positive. So as soon as you see that you've got alternating signs like that, that is an indication to you that it is probably going to be a constant ratio. So I'm not even going to worry about checking for a constant difference here. I'm going to go straight on to checking for a constant ratio because I can see the alternating signs. Okay, so over here from 2 to -4, I am multiplying by -2. From -4 to 8, I am multiplying by -2. From 8 to -16, I am multiplying by -2. And from -16 to 32, I am multiplying by -2. So I've got a constant ratio of -2 in this pattern. So my rule is going to be Tn equals, and then I've got a term over here, with the first term is not the same as my constant ratio. So I need to write that down, and it's also not 1. So I need to write that down as 2 times, and then I take my constant ratio, which is -2. Because it's negative, I have to put it in brackets, and then that is to the power of n minus 1. So that's what you should have got for your rule for question F. Okay, now let's go on to question G. We've got -2, -8, -18, -32, -50. Okay, so I'm going to give you 1 minute for this one as well. Okay, so let's go through that and see what you should have got. Okay, so first of all, over here, -2 to -8, I am subtracting 6, and then from -8 to -18, I'm subtracting 10. So that's not the same, so it's not a constant difference. Now let's check if there's a constant ratio. So to get from -2 to -8, I can multiply by 4, but if I multiply by 4, I'm not going to get -18 over here. So it's not a constant ratio. So now we're going to go and check and see what our second level of differences is going to be. So from -2 to -8, I'm subtracting 6. From -8 to -18, I'm subtracting 10. From -18 to -32, -32 minus -18 is -14. So I'm subtracting 14. And from -50 to -32, I've got -50 minus -32, that's -18. So I'm subtracting 18. Okay, then from -6 to -10, I am subtracting 4. From -10 to -14, I'm subtracting 4. From -14 to -18, I'm subtracting 4. So I've got a second level that is constant of -4. Okay, so that means I'm working with n squared. So it's going to be a quadratic pattern. So Tn equals, and I'm going to have n squared in my pattern. So just like I did in the previous quadratic pattern, we're going to compare this to our square numbers. So I'm going to put 1, 4, 9, 16, and 25, and see how I can get from those numbers to these numbers. Okay, what do I need to do to that pattern to get this pattern? So to get from 1 to -2, I have two choices. I can either subtract 3 or I can multiply by -2. So which of those options will work for all of the others? If I subtract 3 from 4, I'm not going to get -8, I'm going to get 1. But if I multiply by -2, I will get -8. If I multiply this by -2, I'll get -18. If I multiply 16 by -2, I'll get -32. If I multiply 25 by -2, I'll get -15. So I need to multiply all of these terms by -2 to get this pattern over here. So over here, that means that n squared needs to be multiplied by -2. So it's going to be -2n squared. So that's what you should have got for your rule for this pattern. Okay. Then question H, our pattern is 600, 300, 150, 75, and 37.5. I'm going to give you 1 minute for this one as well. Okay, so let's go through that and see what you should have got. So over here I have my pattern 600, 300, 150, 75, 37.5. So this doesn't have a constant difference. It does have a constant ratio. If you divide by 2, then you will get the next term. Now remember, dividing by 2 is the same as multiplying by a half. So our constant ratio is a half. Remember, your ratio is what you are multiplying by. So I'm multiplying by a half. So my rule is going to be Tn equals, and then I take my first term, which is 600, and I multiply that by a half to the power of n minus 1. And we need to remember to put that half in brackets so that the whole of the fraction is being raised to the power of n minus 1. Okay, so that you should have got for question H. Now let's go on to question I. We've got -4, -1, 4, 11, and 20. So I need to give you 1 minute for this one as well. Okay, so let's go through that and see what you should have got. So over here I've got my pattern, -4, -1, 4, 11, 20. Now this pattern doesn't have a constant difference, and it also doesn't have a constant ratio. So now we're going to go and look and see if it has a constant second or third level of differences. So from -4 to -1, I am adding 3. From -1 to 4, I'm adding 5. From 4 to 11, I'm adding 7. And from 11 to 20, I'm adding 9. This has a difference over here of 2. I'm adding 2, then I'm adding 2, and I'm adding 2. So I've got over here a constant second level of differences, which means that my rule for Tn is going to contain n squared. So now let's go and compare this to our square numbers. So over here, my square number here is 1, then 4, then 9, then 16, and then 25. Okay, so now let's see how these compare to what we've got over here. So to get from 1 to -4, I can either multiply by -4 or I can subtract 5. Let's see which one will work over here. If I multiply 4 by -4, I'm not going to get -1, I'm going to get -16. But if I subtract 5, I will get -1. And if I take 9 and I subtract 5, I'll get 4. And if I take 16 and I subtract 5, I'll get 11. And if I take 25 and I subtract 5, I will get 20. So over here, in order to get from this pattern to this pattern, I need to subtract 5 from each of the terms. So my rule is going to be n squared, which is that pattern, minus 5, which will give me this pattern. Okay, so you should have got for question I. Right, now let's go on to question J. In question J, you've got 3, 10, 29, 66, and 127. I'm going to give you 1 minute to find this rule as well. Okay, so let's go through that and see what you should have got. So first of all, this doesn't have a constant ratio. So let's go and have a look at our differences. Okay, so 3 to 10, I'm adding 7. From 10 to 29, I'm adding 19. From 29 to 66, I'm adding 37. And from 66 to 127 minus 66, that is 61. So I'm adding 61 over here. Okay, so then from 7 to 9, I'm adding 12. Then from 19 to 37, I'm adding 18. And from 37 to 61, I'm adding 24. Then from 12 to 18, I'm adding 6. And from 18 to 24, I'm adding 6. So I've got a constant third level of differences here, which means that my rule is going to have n cubed in it. So it's going to be Tn equals something with n cubed in it. So now we need to go and compare this to our cube numbers. So our cube numbers are 1 and 8 and 27 and 64 and 125. Okay, so if I look from 1 to 3, how can I get from 1 to 3? I can either get there by multiplying by 3 or by adding 2. Okay, so over here, if I multiply that by 3, I'm not going to get 10, I'm going to get 24. But if I add 2, I will get 10. If I add 2 here, I'll get 29. If I add 2 here, I'll get 66. And if I add 2 here, I'll get 127. So for all of these terms over here, if I add 2, I will get the terms in the pattern that I've got over here. So I'm going to take the n cubed and I'm going to add 2. So that's what you should have got for your rule for this pattern. Okay, now we're going to go on to our last question for today. So in this question, the pattern is being represented diagrammatically. You need to examine the pattern and answer the questions. The first question that you've got is you need to draw the next structure. So structure 4, you need to draw that. And then question B is you need to complete the table. Okay, so I'm going to give you 2 minutes to work on this activity. Okay, so let's go through that and see what you should have got. So the first thing you had to do was to draw the next structure. So if you look at the first structure, you've got a total of 9 circles where the middle one is white and the outside ones are purple. Then the next structure, you've got 4 by 4 where the outside ones are purple and the middle ones are white. The next one, you've got 5 by 5 where the outside ones are purple and the middle ones are white. And then in the structure 4, you're going to have 6 by 6 where the outside ones are purple and the middle ones are white. So that's what your fourth structure should have looked like. Then you need to complete the table. So in the table, the first block you have over here is the number of purple dots in structure 1. Okay, so over here there are 8 purple dots in structure 1, and then the number of white dots in structure 1 is 1. There is 1 white dot. Okay, now let's go on to structure 2. The number of purple dots in structure 2 is 12, and the number of white dots is 4. Then in structure 3, the number of purple dots is 16, and the number of white dots is 9. And then the one that we added over here, the number of purple dots is 20, and the number of white dots is 16. Okay, so that's what you should have got for those blocks. Now we're going to go on and find out what our rules are to help us to fill in the rest of these blocks in our table over here. Okay, so first of all, to find the rule, I'm going to be using the patterns that I've got over here. Okay, so let's just go, we're going to be finding the rule now. So for the first rule, it's the purple one over here. Let's go and see what is happening in our pattern over here. So from 8 to 12, I've got in this pattern, I've got a constant difference. I'm adding 4 over there. I'm adding 4 over here as well. And then I'm adding 4 over here as well. Okay, so I've got a constant difference of 4. Then 4 is not the same as 8. I need to add 4 to get 8. So my rule for the purple dots is going to be 4n plus 4. Okay, so that's my nth term. It's 4n plus 4. Right, then for the white dots, let's have a look over here. I've got 1, 4, 9, and 16. So if I look at my differences, that is plus 3, that is plus 5, that is plus 7. This has a difference of 2, and this has a difference of 2. And so that means that my rule is going to have n squared in it. Now, if I compare it to my square numbers, 1, 4, 9, and 16, they are the same as what I've got over here. These are the square numbers. So you might have noticed that straight away. And if you did, then that's great. Your rule for the white dots is n squared. Okay, so for the purple dots, my rule is Tn equals 4n plus 4. And for my white dots, the rule is Tn equals n squared. Okay. So now we need to use those rules to help us to fill in the other blocks in our table. So the next one we're going to do is we're looking at how many purple dots and how many white dots there will be in the 10th structure. Okay, so for the 10th structure, T10, for the purple dots, we're going to have 4 times 10 plus 4. So that's 40 plus 4, which is 44. So there should be 44 purple dots in our 10th structure. And then the number of white dots, T10 is equal to 10 squared, which is 100. So you'll have 100 white dots in your 10th structure. Okay, then for the next one, we've been given the number of purple dots, and we've been told that there are 56, and we need to work out, first of all, which structure has 56 purple dots in it, and then use that to help us to work out how many white dots there will be. Okay, so for this one, I'm working with 56, and it is the number of purple dots. So I'm going to be working with the formula for purple dots. Okay, so over here, I'm going to have 56 equals 4n plus 4. Okay, so now I'm going to work out what n is. So I take the 4, I subtract it on both sides, that gives me 52 equal to 4n. So then when I divide by 4, n is equal to 13. Okay, so your n value, or the structure number where you have 56 purple dots, is 13. And then the number of white dots, we're going to use that n value, and we're going to work out the number of white dots. So it's going to be T13 is equal to 13 squared, which is 169. So there will be 169 white dots in your 13th structure where there are 56 purple dots. Okay, and then the last ones we have to do is where they've told us that there are 49 white dots. Okay, so over here I'm going to be working with the 49. Now for the white dots, I'm working with this formula, Tn equals n squared. So it's going to be 49 equals n squared. Okay, now in order to solve this, I need to know what this is with the same exponent as that. So 49 is the same as 7 squared equals n squared. So now because I've got the same exponents, I can now drop them, and I can say therefore 7 is equal to n, or n is 7. So the structure that will have 49 white dots is the 7th structure. So n is 7, and now I can use that to work out how many purple dots there will be in that same structure. So T7 is equal to 4 times 7 plus 4, which is 28, plus 4, which is 32. So there will be 32 purple dots in that 7th structure. and that is how we work with patterns that have constant ratios, constant differences, and also other kinds of patterns like quadratic and cubic patterns. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.